Let's have a look at how we actually use our calculators to figure out some probabilities using the binomial distribution. So first things first, we need to put our calculators into binomial distribution mode from the probabilities menu. Once we've done that, we need to select binomial PD. That's because in this case we have the probability that x equals 26. So we're using the probability distribution. We want to know the probability that x equals an exact value. So if we put that into the calculator, you should get 0.1093. Check that you get that value on your calculator to make sure you're doing it right. So equals is easy enough. Similarly, if we want up to and including a number, so all of the numbers up to, let's say 28, then we need to put our calculator into CD mode. So still binomial CD. CD is cumulative distribution, so the probability of getting up to and including that value. And if we put that in, up to and including 28, we should get a value of 0.5672. It's always worth just having a little bit of understanding of what it should look like. So I've drawn a continuous version here. If you use the GeoGebra file, you'll see that it should be nice, even blocks, like this. Sometimes though, just for speed, it's quicker to draw something continuous, just to help us understand what's going on, just to visualize it. Okay, so 28 would be here, and this is adding up all of those probabilities, all the way down to 0 when they become tiny. And it's saying, what's the probability of getting up to and including 28? So if you put 28 in CD mode, that's what it's doing, all the way up to there. But let's say that I wanted to know the probability that x is greater than or equal to, let's say, 31. Our calculator can only do cumulative distribution, which is up to and including a value. So we're going to need to rewrite this question because we can't do greater than. What we need to do is we need to think, well, what's this going to look like? Again, let's just draw it out quickly. And so on. Always have a think, what's your expected number? So if you multiply these two together, you'll get your expected number, which is your most common. In this case, 35 times 0.8 gives you 28, which is why that is just over half. You would expect there's just over half a chance of getting your most likely result or fewer. Always worth thinking about, just to make sure your answers are sensible. You've not got it in the wrong mode by mistake. So 31, we're kind of expecting some sort of area here, certainly less than half, because the probability of getting greater than your expected value will always be less than half. But as our calculator can only do this side of given values, we want 31, 32, 33, 34, 35. And we want to get rid of all of the values beneath that. So what we can do is we can change this calculation to 1 minus the probability that x was less than or equal to 30. If we take away all of these probabilities, we will just leave ourselves with the ones we wanted. So what we actually put in the calculator is less than or equal to 30. Putting that in the calculator gives us 0.8565. 1 minus that is our probability. Again, less than half as expected. It's a reasonable answer. Always check to make sure your answers are reasonable. It's very, very easy to leave your calculator in the wrong mode.